So this is the second webinar of the Eurisy Members Corner series. This is an initiative that Eurisy started this year to give visibility to the members and favor interaction both among the members themselves and among their respective networks. So we had the first meeting organized by the European Space Agency last month, and we will have a new one by the Belgian Space Office, BELSPO, on the 17th of June on the issue of health and humanitarian actions in Africa. And today it's the Slovak Space Office who is taking the lead in organizing this webinar on the issue of transport. So they took care of contacting 3 companies from Slovakia, which have been successful in integrating satellite-based services and transferring them to the market, which is like the Graal. The space sector has been looking for the last 10 years at least. So we want to know what were the keys to your success, how you went about the development of the market, and we are very interested in understanding what have been the relationship with the Slovak Space Office and how they were able to support you. So without further hesitations, I'll pass the word to Daniel Sagat, who has co-organized this webinar and who is responsible for international cooperation at the Slovak Space Office. Please, Daniel.
Thank you very much, Gracia, for this amazing introduction. I will thank you, first of all, to our participants and as well as to our guests to be here today and to listen to our 3 successful stories in the transportation and satellite services market. I will take a quick introduction to our activities of the Space Office. Just let me start to share my screen. Okay, can you see it in a full screen? Perfect. Thank you. So the Slovak Space Office is actually a very recent player in the Slovak actor. It has been celebrating the first year of existence. So in terms of how did we or how have been supporting our companies over the last 10 years, it was quite limited time, of course, but the Slovak Investment and Trade Development Agency has been very much involved in the Slovak space sector support so over the last 3 years. So I hope that there was some very critical interactions already happening during the last 3 years. The Slovak Space Office is a common project of 2 state institutions. The first one is the Ministry of Education, Science, Research and Sport, which is the traditional stakeholder for space policy issues, and its main activities are to deal with the bilateral collaborations with the European Space Agency, European Union, or the United Nations Scopus, and also plays a very important role in communication within the other ministries and state institutions involved in space sector or having a profit from the space activities. The second element is the Slovak Investment and Trade Development Agency. So it's the recent element for the space sector in Slovakia. As I mentioned, we have celebrated just 1 year of existence, and we are supportive to the Ministry of Education in terms of implementing the national state policies and bringing them to the ecosystem, and in terms of implementation of strategies, supporting the national ecosystem and so forth. So there are 3 main activities that we do. The first one is very important, is the outreach and public relationships. The second one is the sector development, so communication to our ecosystem representatives in terms of companies or R&D institutions. Here also we are very proactive in terms of incubating new ideas. We have launched our first space incubator last year, and it's sort of like a precursor for bigger projects, hopefully in the future, such as the ESA Incubation Center. And the last but not least is the international cooperation. and then opening the doors for our foreign partners in terms of agencies, industry associations, and also critically to bridging the foreign or European and global companies with our national ecosystem companies. And then another element that we do is that we are looking for the hidden potential of Slovak economy or Slovak industry in terms of spinning into the space sector, so spinning non-traditional space actors to space. And then the last but not least, and very important, that we are focusing in our, let's say, the philosophy of our approach is very close to the new space approach, very close to the industry support, commercialization, but of course also dealing with the institutional setup of the European space sector. The international cooperation is, of course, for a country of our size, a critical element. There are two institutions. They are, let's say, sitting on the top of the pyramid of collaboration. The first one is obviously the European Space Agency, that we have been collaborating already for some 12 years. And since 2015 and 16, we have launched a program collaboration within the Plan for European Cooperating State, where every year we have launched so-called PEX calls, where almost more than 60, now it's probably reaching 70 projects were funded via the European Space Agency. And it has been decided this March at the ESA Council, the ESA Council, that Slovakia will be invited to become the next associate member of ESA this year. So this is a game changer for us. There will be a lot of changes and more opportunities. And I hope that also more funding for companies, because we have been seeing over the last years, the participation of companies is dynamically growing, and even we have to looking for new funds to support the ideas and project proposals. Another, of course, important partner is the European Union. Slovakia is a member since 2004, and it's very proactive in utilization of its systems such as Galileo, Copernicus. It's starting to be very proactive in space situation awareness, as well as we are full participating member of the European Defense Agency, and obviously we are taking a part within the structures of the USPA agency. And our office is also very proactive in terms of supporting the creation of Horizon Europe consortia, critical for getting our ecosystem to get the EU funds and to bring their innovation on the market. And from the other organizations, I would say that the list is quite complete. We are the member of the United Nations COPUOS. We have rejoined the COPUOS in 2004 after when Czechoslovakia, the foreign common republic of Czechs and Slovaks, was actually establishing member of COPUOS. Then Slovak Space Office was become a member of International Astronautical Federation, excuse me, last year. So we are very proactive also at within the IFA. And then EUMETSAT is another organization, European organization. We are full members since 2006, and of course member of Eurisy. We have signed a memorandum of collaboration with CNES on the Space Climate Observatory and so forth. Now, a little bit on overview of the space economy. We have more than 40 plus companies active in the space sector. Most of those companies are actually spinning in or spinning off from the other sectors to space. And as you can see, the division between upstream and downstream is almost equal. So it's almost 50-50 upstream and downstream. And especially for the positioning and navigation sector, we have approximately 7 companies proactive, and we'll hear 3 of them today talking about their success stories. Excuse me. Now I'm jumping right to the global navigation satellite system landscape. This is a snapshot of different state organizations. They are profiting or could profit from the GNSS or GNSS services. Of course, the critical stakeholder is the Ministry of Transport and Construction of Slovakia, but then the critical future and also current, but also hopefully in the future customers could be will be the Ministry of Interior, Defense, or Health. Because those are the umbrella organization for multiple state partners or organizations such as police, military, first aid services, or the highway constructions, the National Highway Company, or the Transport Authority when it comes to for example, the airspace, airports, and so forth. And of course, last but not least, we are the bordering country of the European Union, so the border control police is also playing a very important critical role in future utilization of GNSS. Now, just a snapshot of those companies that I've been talking about in the GNSS. The top three, we will hear the stories today, and just the additional to those two, we have a company that is using GNSS technology for intelligent parking services, already pushing or scaling up to the global markets. We have a company that is actually working on the software and audit solutions for GNSS-based applications, or a company that is using a GNSS for car monitoring systems. And this is it. There was very fast roller coaster presentation because now we are going to jump right to the presentations of our successful stories. So thank you very much for your attention via my presentation, and also please don't hesitate to ask any questions regarding the Slovak Space Office activities in the chat, and we will have a particular Q&A session after the presentation. So now I am pleased to give the floor to our first speaker, Mr. Radim Cmar. Hello. Radim Cmar represents the very successful story of company Sygic. The company developed a software based on satellite navigations used by hundreds of million people, including more than 1 million professional drivers. It's the second app in the navigation category worldwide, and the pioneering in hybrid navigation for smart devices such as Google Glass and Apple Watches. So the floor is yours.
Thank you, Daniel, for your introduction. So let me share the slides. Can you see them?
Yes.
Okay. So let me introduce first our company. We are on the market for more than 15 years, and I'm actually almost from the start with Sygic. So in the meantime, as you know, Sygic is probably known by its mobile navigation application on mobile devices, and up till now we have reached 250 million downloads for our customers, and we are one of the most downloaded application in the world, except for giants like Google. Yeah. And we, in terms of the ranking in the navigation category, in terms of the revenue, we are first on App Store now on Google. So as you know, that we are paid applications, so Google doesn't count it for free, but for the paid applications, we are first market. In that time, we acquired a lot of active drivers. So we count monthly 15 million drivers which are using our navigation at least a couple of times during a month. And we are constantly seeking for innovations. And if you would be following our roadmap, you would see there are every year some new features added. Lately, we have added support for CarPlay and Android Auto connectivity. Sygic has approximately 200 employees, and we have headquarters in Bratislava and a development center also in Brno, Czechia. Okay, let me give you some view on the segments we are servicing. So first one, we service the consumer segment. So it is exactly our flagship application, which you can download from app stores and you can use every day. But of course, we are not limited to that. We are also having cooperations with car manufacturers and coming to OEM solutions. So you might have used our application, you don't know what it is, it's a wide label in some cars. Then we are also supporting the transportation and logistics, so supporting the fleet companies, typically the commercial vehicles, fleets and truck fleets. So for the goods delivery, supply chain management, so it means there is some routing optimization across the fleet to pick up goods on time. There is a new rising topic which we're already tackling for almost 2 years. It's electromobility. We are adding into our navigation. Then we are of course doing things related to Internet of Things. So actually the car is one big sensor which is generating a lot of data, and as well as we can connect to infrastructure. So car to infrastructure is the topic we are also looking into, and also the insurance companies, for example, are interested into monitoring of drivers' behavior, which is another topic which we are dealing with, and yeah, it's quite interesting. Okay, let me. Oh, sorry. I've selected 3 topics I would like to touch upon, which are related to satellite topics. And first one is the lane assistance. Lane assistance is something which we are showing when we are navigating a driver. We are showing him the lanes which are available for him, and make sure that he is in the right lane before the crossing. And we were first on the market with this feature. And now I'm just thinking that there is this kind of thinking like, what would be the perfect lane assistance? So currently we're only showing driver where he should go, but we don't know at which lane he is at the moment. But for example, we know that this Galileo potentially is to increase the precision of the signal to the 1 meter. In that case, we could identify the driver is not in the correct lane, and we could kind of alert him and move him, tell him like move to the lane to the right or to the left. So this is something which we are investigating, because the current GPS position, so without Galileo, is not sufficient for this kind of exact lane positioning. So we are only providing information to the driver, but with Galileo there is potential we could even guide him. And of course, there's always a problem with some precisions. So as there are complex algorithms, we could increase the precision. So we can combine this, or we do already combine the GPS position with sensors of the car, which are the mobile device, like accelerometers and gyroscopes. And so this way the algorithms can help to make the position more precise. And so to have this kind of perfect lane assistance, maybe it's a bit tricky for mobile devices. But as I said, we have cooperations with the OEM, with the car manufacturers, and there we have a connectivity to the vehicle. So maybe this precision could be raised, and this feature could be perfectionized. Okay, let me go into another subject, which I find interesting, connected with satellite technology, and it's the traffic modeling for smart cities. So each smart city wants to know the information about their road network, about the health of their network, what's the capacity, where this problem. And so the traffic theory says that what city wants to know is, for example, the speed profiles. So for each road, what are the speeds across 24 hours, 7 days a week? But not only that, there is also the theory says the traffic analyst wants to have the information about fundamental diagrams. So he wants to know not only the speed on each road at a particular time instance, but also the density. How many cars are there? What's the flow. So what SciJIC does is actually we are collecting the so-called floating car data. So each vehicle, when it's navigated, it generates the data and the GPS position with speeds which we are collecting. We are collecting approximately 500 million points each day worldwide. And if this floating car data is interesting, that we can infer speeds actually. So we can basically calculate speeds and come out with the speed profiles. But it's not enough. What we need, what is necessary there is also to know the car density, and this is something which cannot be captured just from this floating car data. And maybe this is the topic of Copernicus imagery, that if we would have this kind of frequent satellite reception, so for example, some cities, we could, with some objective detection algorithms, could calculate those density and match it with the speed, and then we would have really a perfect information and statistics on the REP network. And also, with this satellite imagery, we could perhaps also be checking the parking availability. So these are the things which we are strongly coupled with the smart city solution. We are already communicating with different cities, like we have a cooperation with Vienna, and so tackling these kind of topics. Okay, and the last topic I would like to mention is the map augmentation. So SciJIC is very strong in having its own proprietary format of the map, so we are free to show on map what we want. And so of course we are in what's our ambition is to present relevant information to drivers, which could be the information received from imagery of Copernicus. So more and more important is to show the local meteo information. If there are, for example, floods or pollution, it's something which we could visualize. So it's again a bit with related to smart cities. We have like two functionalities which are interesting to embed this kind of information into our navigation. First one is the geofencing. So see that we can visualize nicely the fences, and which for example could be used that to indicate the pollutions or the zone which we want to restrict from being navigated through. So for example, the cooperation with Vienna City, where we were adopting as a research use case, adapting the routing algorithm such that it avoids certain areas. So another is the augmented reality functionality, where you can attach the camera on the windscreen, and then this reality is projected, which we can augment. And we are already doing like sharp curve warnings functionalities there. But for example, we could also add extra information like road icing, and so all the different information which come from the satellite imagery. Okay, so basically this is about it from my side, and thank you for your attention.
Thank you, Mr. Smart, for your presentation. I'm very happy to see such a successful Slovak global story. And in terms of saving time, let's jump to the next presentation by Mr. Ivan Kratochvíl. He will be presenting the company NG Aviation. The company is developing services based on the GNSS to improve airport traffic management, which allows relevant stakeholders to communicate in a common language and using a common data format while supporting a single core source of truth. So the service supports the digital transition of civil and military aviation, information management and exchange systems. So Mr. Kratochvíl, the floor is yours.
Thank you very much. Well, first of all, allow me to thank Slovak Space Office, but also Eurisy for having the opportunity to be really sitting among the companies which we look up to, such as SciJIC and Microstep. So this is really our honor to be here, and thank you very much for this. As you correctly mentioned, we are active in the field of aviation, particularly civil aviation, with the aim to bring 21st century maybe to the aviation industry, to really increase the use of a digital data and to somehow transfer slowly but surely from paper-based and analog-based information to a digital. But rather than having said thousands of words, let me just quickly play one video. I sincerely hope the Teams is going to allow sound to it. This is going to take just a few seconds.
You need to take care of clicking the button on including the sound of the laptop when you share your screen.
Okay, so then let me just jump directly through the video because it's probably easier than giving you a sound-free video for 1 minute. We, as I said, are focused on the aeronautical information as such, and then the use of various different space assets to improve the aviation industry. So on this slide, you can see that the current information are pretty much paper-based, PDF-based, very analog information that are being exchanged among various different stakeholders. The idea for us was to use the current legislation being proposed by the ICAO, but also then the relevant government legislatory requirements to really move towards a digital use of aeronautical data in a single format, in a language that everybody from airports to ANSPs and civil aviation authorities would be clear to understand, and they could share it from within a single data source. So establishment of a single source of truth information, as we call it in many different other industries. What is the benefit of the digital data for us? It's really the easy understandability of the information, having a visual reference and making sure that my information is being relevant, of the highest possible quality, and of course validating and without any human-made errors is something that is very critically important, especially for the civil aviation industry, as we are all flying and we all want to be safe. Moving forward, our application has really been, or our work has been dedicated to give the stakeholders, and as I mentioned, we are working with the airports, we're working with the air navigation service providers and civil aviation authorities, but also with the third-party system providers and airlines and pilots at the end of the day, because they are the biggest consumer of these data. We offer them a solution that allows them really to very quickly, easily create an information which is very much, which is very digital and very much validated before it's being published. And of course, we have developed our web viewer that is being dedicated to those who need to quickly access all the complex aeronautical information about the airspace structures, about the navigation routes, about the departure and arrival legs and the airports themselves. And of course, all of that is being supported by multiple sub-platforms in order to make sure that everything works fine. So as I've just mentioned, we are trying to cover everything from the upper airspaces down to the very last light of the aerodrome. Maybe now you're thinking, okay, so where is the space assets, or where is the satellite technology being implied? This would not be possible without having a high resolution satellite images. So we are basing our aeronautical information over the layer of a high resolution satellite image, where we can give that information a far bigger of a value, because having understanding of where is my obstacle, where's my airport on a map, which we all can relate to, is significantly better than not having that availability. Maybe on the top of a cherry on the top of our cake is that we are one of the few, if not the only company currently having implementable solution for digital NOTAMs. This is what you can see today. So pilots, for example, when they arrive to Amsterdam Schiphol Airport, Heathrow, Paris, they would have roughly about 10 to 15 pages of such short-coded messages that are telling them what is being closed or what is being limited when they arrive to their airports. This is also relevant for the airspace structures, mind you. So the idea was, you know, you cannot comprehensively understand 12 pages of text-coded messages without a single visual reference. You can simply not, in 21st century, look at the information for 45 minutes and then not fully understand what you are doing. So the idea of a digital data and the visual reference through the satellite images is to give a possibility for a very quickly accessible information overview, understanding what is being closed, understanding how is it being closed, for how long, playing with the time and being able to look back to the future or back in the time in the past on how the situation has been evolving. But also, if I can read, machine should be able to read it. So these are both human and machine readable information that we provide. And then once we're having a digital aeronautical information, which are based on the satellite image again, ready, and we'd use them as a very basic structures for our information exchange, then we realized, okay, let's try to add up various different other data sources. And this is what became really interesting. We have merged our digital data, which is a very dynamic information about the changes of the airspace and the aerodromes, together with a very, very dynamic ADS-B information, movements of the vehicles, movements of the aircrafts. And it's only then when this had become very, very interesting topic to be able to see what is actually happening on the ground in the real time and straight away being delivered to us. Currently, what you can see is our data web viewer. This is the merge of an aeronautical information over the Heathrow Airport together with the movement of the aircraft. Funny enough, many times when people ask us, so what do you actually do? We try to refer back to SIGIC and telling them, look, we're trying to develop something, or we are developing, or we have developed something that is similar to a navigation for your cars, but this should be available to the pilots and the airspace users and so on. So it's really the planning and having the available to see what is actually happening on my airport or in the airspace can not only significantly improve the technical planning of the airports, the airside management and so on, but can really help various different systems, be it regulations within the airspace, use of airspace, the air traffic flow management systems related to the tower, the ASM/GCS systems of the airport. So the idea is really to provide all of the existing systems and information that they can relate to and they can consume it, because there is no point of me creating the data when I cannot use it somewhere else. And the beauty of having these two data sources being merged together is, of course, the real-time statistics and analysis. I can play around with what I'm actually having as a data format. And this has really opened up the whole new horizons in terms of how we observe analytics for the aviation industry, seeing what is my arrivals and departures throughout the day, what is my occupancy on the runway time. You know, you don't want to be keeping the planes on the runway for too long, although you don't want to be keeping them taxiing for too long either. So real-time statistics and analysis are giving you the capability to really improve your operations in the real times as well. And this has been a significant improvement for us and for the whole aviation industry. So this is a major focus of our company today. And of course, the beauty of the statistics and analysis, that everybody wants to have their dashboards and everybody wants to have their results clear to them. So of course, this is something that we've been working on with the multiple stakeholders. We are working with the multiple airports. However, there is a massive interest from the side of an airline industry as well, because optimization and effectivity are the key words. And I'm not going to mention the cost saving, because this is something that everybody is very much looking forward to. So this is the spectrum of our activities when it comes to use of a digital data, use of space assets, space technologies. I do have to at the end say that we have come to this field primarily because of the support of European Space Agency. I think from the very beginning, back in 2016, European Space Agency has recognized the importance of really making sure that there are new innovative companies who are given an opportunity and space to be creative. And I really want to be thankful for to the European Space Agency and everyone who has been part of this, because giving chances to young people, and our co-founders, they started it in their 20s, and they created something that is really groundbreaking. I'm not saying it easy, but there is always a future, and we're looking into it, looking forward. Thank you very much for your time.
Thank you very much, Mr. Kratochvíl, for your excellent presentation. I'm so very happy to see that even from the small country, Slovakia, where there is no big international airport, we can bring some amazing solutions for critical infrastructures.
We have big minds, that's important.
We have big minds, indeed, indeed. So thank you very much. And now I'm very happy to give the floor to our last speaker, Mr. Juraj Bartok from the company MicroStep-MIS. This solution that we will present is bringing actually not the Earth observation solutions to the transportation. So the MicroStep-MIS develops services based on the Earth observations for forecasting in the transport sector. And the company specializes in developing and manufacturing monitoring and information systems in data processing, research, and numerical modeling. The floor is yours.
Thank you very much, Daniel. Okay, my name is Juraj Bartok, and I am head of research department in MicroStep-MIS, and I am a meteorologist. Firstly, a few words about our company. In our history, it's 30 years. We managed to deliver more than 370 aviation weather systems for more than 370 airports. We completed more than 1,000 turnkey projects, and as we are a monitoring company and work in meteorology, we delivered more than 4,000 of professional meteorological stations. We are monitoring in almost all parts of environment, and also we apply this to transport, to the benefit of transport, what the weather is going to bring to transport. So for example, the monitoring part is in meteorology, in marine systems, in hydrology, or in radiation, radioactivity in the atmosphere, or monitoring of this by our manufactured small weather radar. And in transport, we use this information in aviation, road weather, crisis information systems. One note, yes, in this presentation, I will mainly speak about using Earth observation, not navigational system. This is the difference from the first two speakers. But I can say one story as I heard them speaking about navigation. This is a buoy which monitors meteorology and currents and quality of water in the sea. And sometimes it happens that in bad weather, such buoy is floating away from its moored position. Sometimes the sea is so rough that it happens. So, and then we use GPS navigation in these buoys to track them and to catch them and to bring them back to their position. So this is this part. And sorry, we work in more than 80 countries in the world. Now, coming to the core of this presentation, I selected use case from Dubai. Dubai is known for many dense highways, and on these highways, especially in the mornings, there is fog which lowers visibility, and they need forecast for this fog to adjust to adjust the traffic signs, to alert police that okay, this morning there will be fog exactly in the morning rush hour, and you need to prepare the people that something like that is happening. So what is needed for such a forecast of fog? Firstly, these are outputs from numerical weather prediction models. This is models which many of us use but we run a dedicated model for that era. Second thing is output of models based on data mining, and the third part is the actual view of fog on satellites. Here, this is nightly image, and the fog is in white color. So all these areas are foggy. These are high-level clouds, and all this information is finally processed by human forecaster, who releases the warnings for the transportation. On these pictures, you can see comparison of model predictions. The predicted fog is in this dark colors, and on the right side there is fog as also these are nightly images, as is visible on different satellite composites, and here the fog is in orange color, and here on different composite it is in white color, and the forecaster can see that okay, the fog is here as forecasted, but not in this area. But he can see, for example, the movement of the fog, and he can adjust his forecast and his warnings or her warnings. Jumping to sunstorms, similar to fogs, during sunstorms, to forecast and to give warnings before sunstorm, you need a model, and also the satellite images where you see the movement and the real position of the sunstorm. Here on this image, the uplifted sun is in this pink or violet color. Also, not just in the operational forecast, but satellites are also used in tuning, in the process of tuning the dispersion models. For example, this is a picture of untuned, unadjusted model, and this is tuned. And on the satellites, you can see that here in the area of Oman, there are no uplifts, but in the model there were uplifts. So there are some differences in the land use of the model and the reality. So then we need to adjust the land use in the model according to real uplifts, and then we get a more realistic model of dispersion in the area. Finally, this is a short video of a major sandstorm over Arabian Peninsula. It starts here and moves from surface to higher levels, and it influences millions of people here, and also during this time the visibility on the roads decreases, but usually not as much as during dense fog. And on this image you see the same, but modeled by tuned model, and the colors are different here. This pink or violet is the sand. Here everything is the sand, and the different colors mean different height about ground. The red is near the ground on the sea level, and the violet or black is several kilometers high in the atmosphere. So this is a quick overview how satellites can be used and are used operatively by meteorologists to help safer transport. Thank you very much, and I'm happy to receive some questions.
Thank you very much, Mr. Bartok, for your excellent presentation. again, very happy to see that a company operational for decades brought to the market hundreds of services to even more than hundreds of customers globally. Just for a quick wrap up, what we have been seeing today, it's from my point of view a lot of synergies between those three companies, and I think that I hope a lot of discussion will follow up this meeting. You see that the navigation and in EO satellite systems plays a critical role in security, civil security, transportation, modeling, predictions, and so forth. So even in a small market or a country like Slovakia, there has been a lot of great ideas with global impact generated, and hopefully there will be even far more scaling up to the global markets. And the last point of mine is, of course, the role of the European satellite systems. So this is just a teaser for maybe my main Q&A question that I will be very happy to hear some comments. What is the critical role, or how does the ESA/EU systems plays in your services and products? But before I will go to the question, I will give the floor to one of our participants, Cyril. You raise your hand. Do you have a question? I think you can unmute yourself so you can place your question directly to our speakers. I think we can't hear you. So maybe if you can type it down, then I will read it for you, or maybe Gracia, if you can.
Normally, he should be able to unmute himself.
Okay. Cyril Host, there was a hand up, but and you can unmute yourself. So if you have a question, but maybe if it's a technical difficulty, my question, Mr. Kratok will go ahead.
Well, I was just going to say that by the time the Cyril would unmute and have a question, I wanted to really congratulate both of my co-participants on this. And I think in all three of our companies currently, there's a lot of questions in terms of how we can further start our negotiations. And maybe what we should do is to come back in a year's time to see what we've achieved together on that level.
An excellent idea. So we have some 10 minutes. Cyril has no questions. There is no questions in the chat room. So let me get back to my kickoff question to Q&A. So the critical role of the European space-based systems such as Galileo and Copernicus. We have heard that, for example, for Copernicus, there's some, let's say, issues with the timing of the data availability. So maybe we can start with Mr. Bartok. How do you see the future role of Copernicus and European-based systems in your services, in your products?
Okay, we are happy also to use Copernicus data because, for example, in agrometeorology or monitoring of wetlands and monitoring of soil moisture, you can use this Copernicus data, and it is very much connected to meteorology. It is connected to flash floods, how much the soil is containing of water. So it's very, very good. What is not so good on Copernicus that okay, it has very good resolution. It has far better resolution than the images that I have presented in my presentation, which are from geostationary satellites. But the geostationary satellites, for operational use, we need them because they are in frequency of 5 or 15 minutes, and that's what you need for operational warnings. But the Copernicus data are available. These are polar orbiting satellites, and they're available only I don't know, once a day or once in 2 days. So they are better for things like agrometeorology, but not as much for operative forecasting. So in the future, we are happy to see some satellite with resolution of Copernicus and time resolution of geostationary satellite.
Maybe additional question is that there are already on the market private companies, private satellite operators providing, let's say, twice daily imaging of a certain region on the Earth. Do you also consider those private companies or private services? If you do, how it would change, for example, the pricing of your services or the technology, the innovation itself?
It's still the question of future, because still 2 times a day is not enough for operational meteorological forecasting.
Thank you very much. I will now give the floor to Mr. Cmar, and I'm very curious because your company is globally successful entrepreneurial achievement, and how do you cope with new systems coming to the market, such as the Galileo systems and, for example, the new features the Galileo could provide the customers within the applications they will download? Could you tell us something a little bit about the transition from the, for example, GPS and allowing the new Galileo services to your application?
Yeah. Actually, SciGIC is a consumer of the GPS position. Yeah, so this is like our core business to have the most possible accurate GPS position, such that the cars are navigated well, especially in difficult scenarios like crossing, turnings, even more difficult in tunnels and where the signal is missing. So yeah, also in where there are big buildings, so there are reflections and the signal deteriorates in terms of precision. So we definitely appreciate the more precise, even more precise positioning of the signal, which would really help our drivers to be navigated better. As we are somewhere on the downstream, we are basically dependent on the operating system of mobile devices, for example, what they offer us. So Galileo is a bit hidden for us. So we are talking to the operating system, and if what position he gets us, that's something we need to work with. But this is for the consumer market. If we can but we can move also to the car manufacturers market, where we will have a connection to car data. So and then I think these things could be improved, and this is we could take the full advantage of this better precision. And as I said, it's an interesting opportunity to use it for lane assistance. So this is the feature our drivers really appreciate, and as I mentioned, they're only now provided with the information like where are the lanes, and we show them where they should be, but we don't exactly know where they are, such that we could alert them. So definitely it's an interesting opportunity for us, this increased precision, but we need to have it somehow delivered through third parties.
Thank you very much for this a very interesting insight. Now I will turn my attention and one of our guests' attention to Mr. Kratochvil. We have a question from you from the audience, but before I will say the questions, I have one of mine, and it's maybe a very quick response. The airports in general are very institutionalized and very, let's say, not very open for new technologies, especially for the satellite navigation technologies. So very conservative mind approach. How do you see this in your business? This sort of likewise more approach of traditions than innovations.
Thank you for the questions. Mr. Bartek would probably know that as well, the answers on how that is. I mean, in general, and now I mean this with the most utmost respect towards the aviation industry, but when we look around the various different industries in general, there could be a far greater innovation implementation and far more new technologies being innovated to the aviation sector in general. What we see as crucial is to educate, to talk to our customers and clients, and to prove ourselves that the data that we are creating are not only as good as the analog-based information, but far superior when it comes to use, when it comes to understandability, and when it comes to further cooperation of these information with other existing systems. So it doesn't really necessarily mean that you are having one data source and you are using only for one system. The idea is that if you are having one general information as a single source of truth, you make sure that you use it in all of your systems that are currently in place. Now, when we talk about the various different data merges, then this is of course beautiful. And when I saw Mr. Bartok's presentation about the weather, of course, weather is super critical to the aviation sector, and having the ability to fuse these information together to give a single picture overview to operations, it's very important. And this partially also answers the question of Mr. Cyril, because yes, the ADS-B data that we are receiving are complex. They give us a lot of different information, and we're really expanding only and exploring what we can use the data for. Wind is definitely one of them, but there are elements such as speed today, like a simple question of an airport planner or airport coordinator would be, how fast is my aircraft going at this particular time? Is it going too slowly? Because if it goes too slowly on a taxiway, then it slows down the whole operations, and I want to be notified immediately. Now, currently, these informations are lacking behind. So, having the ability to bring this information forward and bring it up can really improve the operations of the airports, but can definitely improve the informations on how our skies are being managed and run. Because when you look at the sources such as the Iron or Flightradar 24, and you look at the amount of traffic that is up in the air, it's incredible, and one little thing can really affect it very much.
Thank you. That was a very extended answer, but very, very pointed. And now I give the floor to the last question. I see the Mrs. Katarina Belobradova is raising her hand, so you have the floor.
Hello. Can you hear us? Okay.
Yes, we can.
Can we hear each other? Okay. I don't know if you see me, but okay. No? No.
We don't see you, but
yes.
Yes.
Now we do.
Yeah.
Okay. Actually, I am EU Space Program National Expert regarding EO and Copernicus. My name is Katarina Belobradova, as my colleague from Space Office already introduced me. And I would like to ask you a question. It's regarding the, maybe it's linked to all of you, I think. And the question is, what you see the possibilities if Copernicus would be on a more frequent basis? Would you add all the meteorological elements in your applications to inform drivers or airport or managers or pilots into your applications? Like in Germany, we saw that this flooding happened. So this could also, let's say, inform citizens on time not to drive or not to go on a highway when there is a high risk on flooding, or maybe when it's regarding to planes, then it could be also the problem that there is a storm and so on. So would you link all these hazards into your applications? And maybe I see the possibility there that it could avoid any catastrophes that are happening already. Thanks.
Thank you. Who would like to start with the response?
Maybe I can start.
Okay.
I heard the mention about drivers. So indeed, this kind of information, as I also mentioned in my presentation, would be valuable for drivers to see this information about storms, about the local weather, about floods, pollution. This is all also a bit related to smart cities. And sure, but we of course we need to see some economical viability of such a service to provide, because as we know, this is maybe this kind of information might be needed in real time, so it needs to be processed. I don't know what would be the frequency of update, what would be the resolution, but and take some data processing behind. We are already investing in machine learning, object detection algorithms, and these kind of things. So I think we're well positioned to process such data. But anyhow, I think this is a kind of room for third parties. Maybe the colleagues here in my presentation, that they could pre-process such a data and provide them to us as services. Because there are always some nuances there, and it's really typically requires a lot of focus to have that data well processed. So definitely interesting for us, attractive, and yeah, the frequency of updates would be crucial here.
Thank you, Mr. Zma. Mr. Bartok, you are muted.
As I said, more frequent Copernicus images would be very good, but I see it's a bit in the future. But to respond also to Mr. Zmar, it is yes, it's about the service and cooperation. For example, there should be some meteorological service and with models which observes the thunderstorms, the flooding, and so on, and then issues warnings, and then these warnings can help drivers in real time to avoid that area, so they can pop up in the navigation or something like that.
Thank you. Mr. Kratofil.
Well, from the aviation's perspective, I think what is very fair to say is that there is already a very good knowledge when it comes to the weather information, especially up in the air. The other important element is that the online connection has only been introduced to the airplanes very recently. So, and there is still a huge gap that could be filled, and there's a lot of things that could be improved. So definitely, from my perspective, I see that there's going to be quite a big development, and I'm sure we can all agree there are new opportunities coming up with the new technologies being available. I can only agree with the argument saying that the more accuracy and the more frequency of the information, the better for every single user of that information. So that's how I see it.
Excellent. Thank you very much. So ladies and gentlemen, the time is running very fast, and we are coming to the end. And before I give the...
We actually, sorry, we also have a question in the chat.
Oh, sorry, I forgot that.
Even if we're a bit late, we can just very quickly take that one.
Sure, but I think if this was to the question to Mr. Kratofil, we already pointed it out.
Oh, okay.
Yes,
Okay.
yeah, you mentioned the ADS. Yeah, thank you. I was monitoring that. But thank you very much, Gracia. It was always good to know that some I overlooked. So we are coming to the end, and before I give the floor to Gracia again to wrap up, I will do on my behalf a small wrap up because the topic of today's session was also technology transfer in transportation, and technology transfer and innovation in transportation. And I have noticed several critical elements that are spinning around the transport and GNSS sector as critical elements for innovation technology transfer. And I would point some, such as education, communication, data availability, such as timing or real-time data, the capability of data collection. And then, of course, those have a very important effect on others spinning off let's say, domains of transportation and GNSS use or EO use in transportation and traffic security, if it's land-based or air-based. And even the smart cities as a very fast-growing domain of implementing the space-based sectors or space-based systems. So I would like to say again, thank you to our panelists for the excellent, insightful presentations, and I wish you a good luck for your future in innovations and technology transfer. But also, I hope that in a future collaboration between your three companies, I had already have feeling of a small hackathon going on here during the session. So I'm very happy to see that. And I just want to guarantee that the Slovak Space Office is here to help you in communication, identification, and also networking with other companies. And last but not least, thank you, Eurisy, for giving us the opportunity to being here today. We are very proud member of you and what you're doing for our community and community of people and companies and institutions is great. And thank you very much again.
Thank you, Daniel, and thank you to the speakers. We will be definitely in touch with them because, as you know, at Eurisy, we collect success stories from the final user's point of view. So, I mean, we will be happy to interview some of your customers who could tell us from their point of view how the use of your services help them to provide the better services to their own customers. So thank you so much. It's been very, very interesting. We take duly note of the criticisms made to both Copernicus and Galileo and to the need for them actually to provide better data and to make your life easier for the integration of their data. Galileo is anyway doing, I mean, a big work also from their side to work with car manufacturers and phone manufacturers to make your life easier in that sense. All the participants, as Annalisa points out, will have access to the recordings afterwards. We will write a short article. While our next meeting is for the 17th of June, it will be the Belgian Space Policy Office, which is one of the oldest members of Eurisy, explaining about how they use Earth observation in urban areas in Africa to assess vulnerability. So we will focus on health. So thanks a lot. I wish you all a good lunch soon and a good end of this working week. I hope we will gather together again very soon. Bye.
Thank you very much.